Hello. Right, back again. Got a couple of lessons to do today. One of them is called energy dissipation, which is topic P1.6, and the other one is energy efficiency. Now, when I'm talking about dissipation, I'm talking about losing some of the energy that we wanted. Dissipation means it's lost, it's spread out, it's gone all over the place, and it's harder to capture. So let's first of all consider if you are riding a bike. Now, if you're riding a bike, you are using the chemical energy stored in your legs, and your ideal outcome is that you turn all of that chemical energy into kinetic energy to make your bike go forwards. But some of the chemical energy that you put in is lost. It's lost through friction. So if you was to look at, for example, if your tyres weren't pumped up very well, your wheel might look like this, might look a bit flat and squishy, and so lots of it is in contact with the ground. And all the time it's in contact with the ground, it's sticking to the ground because they're rubber tyres and they're made to have lots of grip and friction on them. So you are losing some of your energy by having a large part of your wheel in contact with the ground. And so that energy is lost as thermal energy. It heats up the thermal store of the air around you, and it gets spread out or dissipated and harder to use. So you've lost some of that energy. So if you are wanting to be an efficient cyclist, like a racing cyclist, where you want all of the energy that you put in to be turned into kinetic energy, or as much as possible, you try and reduce all of these energy losses. So you will have your tyres pumped up very hard, so there's only a very small part of the tyre that is in contact with the ground. You're not losing too much energy there. Also, obviously, you want to be streamlined, so you're not losing any energy by heating up the air as you're going through it. You want to cut through it nice and easily. So when you are cycling, or if you're doing motor racing or something like that, you want to make as much of the energy you put in turn into what you want it to do, and some of it is lost along the way. The ways you can reduce it, like I said, you can pump up your tyres, you can keep things oiled properly and lubricated so that you don't lose too much thermal energy, and that thermal energy is lost to the surroundings and it's harder to capture. Okay, I think I've covered that, and that's a whole lesson there, so that's not too bad. So let's look at the next one, which is all about efficiency. Energy efficiency. Now, there's lots of talk about having an energy efficient house. If you've got your heating on and you want to heat up your house, you don't want to be losing a lot of that energy through sort of gaps in your windows or lack of double glazing or anything like that. And so you want your place to be as energy efficient as possible. In other words, you don't want to lose too much energy. And sometimes we use these things called a Sankey diagram. Now, if you see one of these in the exam, you should be very pleased because they're very easy to follow. They might look a bit complicated when you first see them, but what it does is it shows you where all of the energy goes. Now, if this was to represent, say, a light bulb, and let's say I put 100 joules of energy into my light bulb. Nowadays, light bulbs are much more efficient than they used to be. Like about 10 years ago, they were what we called incandescent light bulbs, which was a glowing piece of white hot wire inside a bit of glass, and that generated so much heat that it gave off some light. But as you can probably tell from what I'm saying, is most of the energy went in there as heat, and so it was all wasted. Nowadays we have energy efficient light bulbs, mostly LED light bulbs now, which just turn nearly all of the electrical energy straight into some light energy. So if this was an energy efficient light bulb and I'm putting 100 joules of energy in, if I get 80 joules of light coming out, how many joules would I get of wasted energy? And you can work that out quite easily. It's 20 joules of thermal energy, because that will still get a little bit warm. And then if I was to say to you, how efficient do you think that light bulb is? You say, well, 80 of what we put in, of the 100 that we put in, was useful, so I'm going to say it's 80% efficient. And that's without me telling you any maths at all, it's just quite intuitive. And so that is 80% efficient, because 80% of what you put in is turned into useful stuff that you want to get out, and 20% of it is wasted energy. So we now need to look at ways of calculating that when the numbers aren't quite so straightforward here. Now, this was intuitive, but I will give you an equation that you'll need to use in the exams, which you'll need to remember, which is this, and the efficiency is the useful energy that you get out divided by the total energy that you put in. So for example, the total energy I put in here was 100 and the useful energy I got out over here was 80. So 80 over 100, that works out at 0.8 or 80%. So the numbers will not be as straightforward as this in the exam. So you would have a question that goes something like this. What should we say? Okay, so let's talk about a car. You put 80 joules of energy in the petrol, and of that 30 joules becomes thermal energy, 10 joules is sound energy, and it would ask you how much energy is turned into kinetic energy, which you should be able to work out because you put 80 in, you've used up 30 and 10, which is 40. So you can say, well, 40 joules is turned into kinetic energy, and then it asks you to calculate the efficiency, and the efficiency is the useful energy that you got out, which we said was 40 joules of kinetic energy. The total that you put in was 80 joules of energy from the petrol. I'm going to call that the chemical energy from the petrol, and you do that calculation and you get an answer of 0.5 or 50% efficient. And that's it, really. They will ask you in the exams what type of energy is lost, and ask you to calculate the efficiency, but it's really not too tricky. All you've got to remember is the efficiency. Okay, we've done some rhymes so far, let's do another one. The efficiency is the good stuff out over the total put in. Energy or power, it's all the same thing. We'll come back to these from time to time, but we're going to keep looking at those. So if you want to do some work on this, and I'm sure you do want to do some work on it, again, we're in this book here, and we are doing topics P1.6 and P1.7. And that's it, very short video this time. Catch you later.